Now we can talk about absolute value inequalities. First thing I'll say, if you haven't seen the introductory lesson on absolute value in the lesson Positive and Negative Numbers 2 in the Arithmetic and Fractions module, I strongly suggest that you watch that lesson first before you watch this one, because that's where we explain this basic understanding of absolute value. So if you're confused with absolute value as distance, why are we talking about absolute value and distance? It's explained in that lesson. I'll assume that you have watched that lesson already. So recall the distance definition of absolute value. The distance of x from 0 is absolute value of 0. We take the absolute value of any number in the number line, we get its distance from 0, distance from the origin. If we want the distance from positive 5, well, then we have to subtract. Subtraction is the basic way that we find distance. We subtract and take the absolute value. So absolute value of x minus 5. And so if I plug in x equals 8, then I get x minus 8 minus 5, absolute value of 3 is 3. And so 8 is 3 away from 5. And if I plug in 2, then I get 2 minus 5, negative 3, absolute value is 3. 2 is also a distance of 3 from 5. Now suppose I want the distance from negative 3. Well, again, we would subtract. But here's the tricky thing. When I subtract a negative, it becomes positive. And so that's confusing to some people. They see this positive and they say, well, why is it that we get a positive when it's a negative we're concerned with? Well, it's because we're subtracting. And when we subtract x equals negative 3, we get x equals plus 3. And one way to think about this is with ordinary numbers. Suppose x equals negative 4. Well, how far is negative 3 from negative 4? Well, it's right next to it on the number line. It's 1 away. And if we plug into the formula, we get absolute value of negative 4 plus 3, absolute value of negative 1 equals 1. So the point negative 4 is a distance of 1 from negative 3. But if we plug in positive 4, well, then we get 4 plus 3, absolute value of 7 is 7. And that makes sense because negative 3 is down here and positive 4 is up here. And so we'd have to go, if we started at 4, we'd have to go distance of 4 to 0 and then another 3 to get to negative 3. So that would be a distance of 7. So even though this is anti-intuitive, the formula actually works when you plug in numbers. So in general, if we want the distance from a positive value of p, then the formula would be x minus p. And if we want a distance from negative p, then it would be the absolute value of x plus p. And again, some people are confused. How come the signs swap here? And you have to remember that it's a subtraction. Here we're subtracting a positive. Here we're subtracting a negative. And subtracting a negative results in addition. This way of thinking about absolute value in terms of distance is enormously helpful in understanding inequalities that involve absolute value. Here's a practice question. Express absolute value of x minus 7 is less than 3 as an ordinary inequality. Pause the video and think about this for a moment. Okay, so what we're saying is that if we start from 7 on the number line, we can go up to and including a distance of 3 in either direction. So if we went down 3, we'd get to 4. If we went up 3, we'd get to 10. Those are the two endpoints, and those are included because we have a less than or equal to sign. So it includes the endpoints. And so it would be everything from 4 to 10. Everything is allowed from 4 up to 10. So that would be 4 less than or equal to x less than or equal to 10. So that is an expression of this absolute value inequality as an ordinary inequality. Those two express exactly the same information. Express this ordinary inequality, 5 is less than x is less than 17, as an absolute value inequality. So now going the other way. Well, let's talk this through. This is a bit tricky because notice that the absolute value inequalities are all about some center point and how far away you can be from that center point. And so the first thing we need to do if we're going to turn it into an absolute value inequality is find that center point. And the way we do that is we take the average. So what's the average or the midpoint of 5 and 17? We'll add them up, divide by 2, we get 22 over 2 or 11. And notice that 5 and 17 are both a distance of 6 from 11. In other words, if we start at 11, go up 6, we get to 17. We go down 6, we get to 5. And so we'd write this as the distance from 11 is less than 6. In other words, we could go all the way up approaching 17, but we can't actually get to 17 because this is a less than sign, not less than or equal to. And so that's why we have a less than sign here, not less than or equal to. Again, this ordinary inequality and this absolute value inequality state the same information. Here's a practice question. Pause the video and then we'll talk about this. Okay, here we have a graphical representation of an inequality. And a few things to notice. We have open circles at the endpoint. So open circles, that's how we would say that the endpoints are not included. So we're including everything down to 20, but not 20 itself. So in other words, if we were going to write this in terms of numbers, we would say 20 less than x is less than 90. So in other words, 20 and 90 are not included. That's why we have open circles. If they were closed circles, these would be less than and equal to signs. So the very first thing we need to do to turn this into an absolute value inequality is to find the midpoint. The middle of the region is the average of those two endpoints, 20 and 90. When we add them, 20 plus 90 is 110. Divide by 2, we get 55. So 55 is the middle. And notice that if we start at 55, right here, the middle, then how much are we going up or down? Well, we're going 35 up or down because if we go up 35, we get to 90. If we go down 35, we get to 20. So in other words, what we're saying is starting from 55, we can go up to, but not including, a distance of 35. So that is absolute value of x minus 55. The distance from 55 is less than, but not equal to, 35. And so this is the correct answer. We remember this, go back to the answer choices, and choose answer choice D. Express the region -3 less than or equal to x less than or equal to 11 as an absolute value inequality. We'll notice a few things. First of all, notice that the endpoints are now included because we have less than or equal to. We still need to find the midpoint. And so we'll take the average, we'll add those two up. So -3 plus 11, positive 11 is positive 8. Divided by 2 is positive 4. So 4 is the middle. If we start from 4, we go up 7 to get to 11, or we go down 7 to get to -3. So the distance from 4 is going to be less than or equal to 7. The distance from 4 is less than or equal to 7. Go back to the answers and choose answer choice C. We demonstrated how the distance understanding of the absolute value makes inequalities involving absolute values very easy to solve.